So at this point, everything, as far as we know in terms of physics, seems to be working. So we are in a good spot. We've cycled through making a small change, testing it, debugging it, and we can see how Unity's interface, editor interface, makes it easy to do a lot of debugging and testing, so that when we move on, we know where we stand, that we know what works and what we have to do. So at this point, let's go back and look at our plan of action. So we kind of did the 2D physics aspect. We've done all this. So I think the next thing to do is to create a control manager. The idea behind a control manager is that a control manager manages the ship's controls. So in this case, we'll create some manager object. We'll call it control manager. Add a little script called control manager, which is our convention. Okay. Uh-oh. And edit the script. And the first thing we do is we say public static control manager inst, and then we say void awake inst equals this. So this is, and what should this do? Well, it should respond to the arrow keys, up arrow, down arrow, left arrow, right arrow, and control ships. So we'll basically have a set of if statements. If get input dot get key, and we'll say up key code dot up arrow, right? What do we want to do? We want to say increase the speed, right? So when we say selection manager dot inst dot selected entity, there we go, dot desired speed plus equals by some increment, right? What is the increment? Let's say 1 knot, 5 knots, whatever we think is a good increment. Let's say let's say 1 knot. We should probably have this set over here. Something like public float delta speed equals 1. Okay, then we can just say delta speed. We have to make sure that the desired speed doesn't go over the maximum speed, but we'll do that a little bit later. Right. So what we'll say then, I didn't cut and paste properly, so let's try this again. Okay. Left arrow, right arrow, right? So up arrow, down arrow, and down arrow decreases speed. Right? Okay. And then up, left arrow, and right. So left arrow should turn left. So how do we do that? I'm going to say selected entities desired, desired heading, you want to decrease it by delta heading and public float delta heading equals do it in increments of 2 maybe. This doesn't work because if it's less than 0 we're going to have issues, right? If it's greater than 0 we'll correct for it afterwards. So here and that should be it. And what we want to do is here what we'll say is speed equals utils. We define the clamp function, right? It gets to be very useful. Clamp, and what is it? The value is desired speed. So selection manager dot ints dot selected entity dot desired speed. And the min is, oh, this is long. Manager dot ints dot selected dot min speed. This is getting really long, so I want to put it in the next line. And max speed. Okay, so we clamp it, and over here, what we have to do is we change it to, so I'm going to put these two together. These two together, and this one, and then we're going to put, yeah, that's fine. Then here I'm going to say selection manager dot ints dot selected entity dot desired heading equals, I think it's degrees 360. We basically wanted to go back to degrees 360 dot degrees 360, same thing. If it turns negative, it's going to make it into the right angle. If it turns positive, it's going to make it into the right angle. And everything should be good, I think. Let's see how it goes. Uh-oh. That was an extra there. Alright, so that should be fine. Let's go back. Okay, delta hand spinning, sounds good. Alright, who is selected right now? TTG51. Alright, I'm going to press the up arrow, count down from 3. 3, 2, 1. There it goes. Desired speed is 1. Desired speed is 11, and it seems to be accelerating real fast. So, turn left, nicely done. Turn left by a lot. 270. Okay, that's what I wanted. Keep pressing the right arrow, and I'm going to make a turn. While I'm pressing the right arrow with my left hand, I'm zooming back out so you can see it. You can see desired heading go all the way up to 90, yeah, 96. Okay, maybe not 96. We can make it go to 90. Desired speed, I want it to go faster. Okay, it's not going faster anymore. That's as much as it will go. Okay, so that works. Seems to work. If I go back here and press tab, I should be able to get this guy to move. All right. The thing turns really fast, so that is really fast. Right, so this is working remarkably well. All right, okay. What else do we need to worry about? So that's a control manager. Control manager is doing well. It's controlling the entities. I think this is what we needed from it. Okay. If there's any more controls, for example, if we need to worry about page up and page down for flying entities to control altitude, we'll be adding it here. And making changes to desired altitude and things like that. That seems to be it. Oh yeah, right. And now we need a camera manager. Okay. Well, let's create a camera manager. How do we create a camera manager? Well, we add it here. No, I'm not creating a camera. We already have a camera. Creating a camera manager. And what should the camera manager do? Well, it's over there. That's not helpful. Basically, we're adding a script. We're going to call it a camera manager script. And it needs to do lots of things. All right. To create a camera manager, what we want, if I were to draw it, would be something like something that I'm going to draw here. What I want is, let's say, I draw a circle, right? So I want a circle like that, duplicate it, a circle under it, duplicate it, a circle under it, and draw one of these square shapes, and that's my camera. So what I need to do is draw, like set up a bunch of scene nodes so that one is a child of the other, and we end up with a hierarchy like this. Okay, I'm gonna catch this and make it a little thicker. Is this how I make it thicker? Not there, no, it's too thick. And then how do I get its properties? There we go. Okay, I like it. And same thing with this. Full point and a nice orange color. Okay, so this is our camera, right? This is going to be our, let's say, roll node. This is going to be our pitch node. And this is going to be our yaw node and movement node. So all translations and stuff will be done to this node in the X, Y, and Z directions. Any yawing around the y-axis is going to be done to this node. Any pitching, that is moving the tilting the camera up and down, rotating around the x-axis, will be done on this node. We don't have to implement roll, but if we had to, and this turning around the z-axis, rotating around the z-axis, would be done to this node. This way, we keep each of these rotations separate, which makes it easy to control the camera, and it mostly makes it easy to do the actual rotations, because that's the way humans think rather than directly rotating the camera, because experience shows that if you don't do it right, and this is the right way to do it, um, the camera ends up in some weird rotation and you cannot recover back from it until you like reset the entire thing. And so this is what we are going to move. Um, so first, um, for the real-time camera, real-time strategy camera, that is like the God's eye view camera, the view from 60,000 feet camera, we're going to attach this entire tree or subtree to a node, and we'll call it the RTS camera node. Then when we want to go to the third person, we'll have a node associated with every entity, and then detach from the RTS camera node and then attach to the ship's camera node. So you'll see what I mean in a little bit. So camera rig. Okay. So we'll go and we'll create a node, which is an empty game object here. We'll call it the RTS camera rig. Okay. And I'm gonna put it at the very top, even above the main camera. Below this, I'm going to create my little hierarchy of 3 game objects: yaw, translate, pitch, and roll. Then I want to put the camera as a child of that. All right. Is everything zeroed? Oh no, this is not good. Reset position. Okay. 0, 0, 0. Okay. We'll call this the yaw move node. Oh, let's not nice way to say it. Yaw move node. We'll call you the pitch node. We'll call you the roll node. Okay, so if we do this part, and this subtree is basically shown here. Okay, this yaw move node and everything underneath it is shown here. All right. So now that we have this, we have to, in the camera manager, get references to this, 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 and then whenever we need to move it, we move the camera with this. Whenever we need to pitch it, we pitch it with this node. Whenever we need to yaw, we yaw the camera with that node. We don't currently use the roll node for this particular thing, but you can imagine later on, if you're doing airplanes and other things that might need to be pitched, you can go ahead and think about changing this particular node. This also works, as you can imagine, for airplanes and things, where you might have to yaw, roll, and pitch. And if you take flying lessons, they will talk to you about yaw, pitch, and roll. Or if you fly Microsoft Flight Simulator or other flight simulators. Okay, so let's go to the code and make some space. Since it's a camera manager, we'll start by saying public static camera manager inst. Then we'll say void awake inst equals this. Okay. And here we're going to write some code to respond to key presses. So if input dot get key up, let's say key code, let's just do motion. Okay, W. What do we do? Well, okay, yeah. What do we do? Well, think about it. what we have to do is not very huge stuff, but simple stuff, right? What we have to do is move it. So what we're going to say is, well, what are we going to move? Well, we're going to move the yaw node. Okay, so I need a reference to the yaw node. I'm going to say public, and this is a game object. So game object yaw node, and I probably need a access to the pitch node. And although I'm not using it, I probably want to get access to the roll node. And then I do want access to the top level node, the RTS camera rig node. So public game object camera rig. We just call it RTS camera rig since that's our convention. Game object and the script and are named the same thing, aren't you? Public game object RTS camera rig. Okay, and just so we'll say this is a child. Child of RTS camera rig. This child of yaw node, child of pitch node, right? And camera is child of roll node. Just so anybody reading this code knows what the assumptions are and what assumptions are made for this thing. Okay, we're going to say yaw node dot transform dot, should we translate it? And how do we want to translate it? Well, let's see. Move it in the direction and distance. Transform relative to, translate relative to, there's various, okay. Okay, so what we want to do is okay, so I'm not sure how we're supposed to use it. So why don't we look at some documentation? So let's say Unity transform documentation. Transform dot translate. Okay? So this is what I expect you to do. If you want to do something and you don't know how to do it, you look it up. And what this class teaches you is what you need to look up is translate. And what you need to look up in terms of translate is in Unity, you're translating transforms. And I'm going to go look it up for the manual for the Unity version we have. So if we look at this, I want to go forward 1 unit per second times star delta time. That's what I want to do. I want to go forward when I press the up arrow. So this is what I want to see. So it's direction, time delta, so everything is relative to time. So going back here, I'm going to say translate vector 3 dot forward star time dot delta time, and I'm going to multiply it by camera speed, right? Okay, I'm going to say move speed. Does that sound good? I should just basically say camera move speed, so it's clear what I mean. And then I'm going to declare it here. I'm going to say public float camera move speed equals, we want it to move relatively fast, so we'll say 500 units a second. So vector3.forward is 100, well, 1 in the direction the camera is pointing. And camera move speed basically multiplies by 500, so instead of using 1 unit, instead of moving forward 1 unit per second, it's going to move 500 times 1, which is 500 units per second. And the per second you get by multiplying time by delta time. That actually doesn't require. So if I were to cut and paste this a few times, I can do backwards, right? Camera code dot s, and this would be translate. No, it's 3 dot. Is there a back? I wonder. Oh yes. So even though I don't know all the, I haven't yet memorized all the translation constants or vector3 constants. That's what IDEs do. They leave your mind to burden itself with the overall logic and leave this to the IDE. So A means move left, and D now means right. I'm assuming there's a right, of course there is. Okay, so that takes care of motion. So we've written a lot of code. I mean, I've written 8 lines of code here, and I had to look it up before we could learn it. I'm very uncomfortable with moving on without some kind of testing, because then I won't know what's going on. So did it compile? Okay, and we have the right node. Oh, well, I haven't actually told the camera manager what, I haven't actually connected this up. So if I had gone on like that and tried, I'm going to press the A key. Okay, you can see that there's a bug, right? I press any of the keys, I'm getting problems, and the problem is it doesn't know what these are. So stop, assign this to this, assign this to this, assign this to this, rel node to this, and we are, save it, play it, and now things should be a little bit better. Hey, I'm pressing the D key. Oh yeah, I'm moving right. Oh yeah, it's moving up and down. Okay. Okay. So the problem now is that I expect the movement to be a lot more continuous. So get key up is not what I want. I just want to get key. Okay, so it can move multiple times when I do this. So Control P to hit play. And I've got ASD. Oh yeah. Right, nicely done. Maybe it's moving too fast. And I can follow this guy around. I can be in front. It looks nice. Yay. Okay. Oh, I wish I could go up and look down. All right. That's what I have to work on next. So I want to do up and down as well. I got left, right, forward, back. Let's do up and down. So for up and down, I wanted to use, in the assignment, I believe I wanted to use keys close to WASD. QE was for yawing. So RF was for going up and down. So R is up, F is down. This is just up. Oh, there is an up, and there is a down. Nice. They've done a good job with their definitions for vectors. So this should, I'm thinking this should work. So I'm going to press play, and I'm going to press R, and well, that's a problem. Well, I'm inside the ship. Okay, maybe it's going a bit too fast. Maybe this should be, let's say 100, right? And then things, oh, it's not 0, 100. Okay, and then things should go nicely. All right, okay, this is better. Oh, it's got nice. It's almost like you're there. Okay, so that worked. So I should just change this to 100 and leave it at that. Save it. Now note that this will override the value here next time it runs. This is how Unity's editing works. Editor editing works. All right, so now I need to do yaw and pitch. Okay, so if I say if input.get key and then key code dot q, it's not quit. Oh, I do need a quit button. What do? Well, I'm still dealing with the yaw node dot transform dot what do I want to do? I want to turn it, rotate it to the left, right. What I want to do is local Euler angles dot y minus equals some turn speed, yaw speed, or something like that, right? Times time dot delta time. So I need to make a bunch of changes. So first, what I'm going to say, I'm going to need something that tells me how fast I should be turning. Float, camera, turn rate. That's what I should be saying. Equals, let's say 5 degrees per second. No, that's too slow. 90 degrees per second. 1, it turns all the way. No, that's too fast. 10, let's say 10 degrees per second. And we can always adjust this, not a big deal. So first of all, we'll say that. Camera, turn rate, start time, dot delta time. Okay. We can't do this because we can't directly access the y component. So now I need another vector. Vector 3, and I'm going to make it public because I want to make sure it's fine. Public vector 3 yaw angle yaw Euler angle equals vector 3 dot 0, and what we're going to do is we're going to say yaw Euler angle equals yaw node dot transform dot local Euler angles, and then we're going to say for this yaw node dot transform the local Euler angles equals yaw Euler angle, but we first need to change it. So yaw Euler angle dot y minus equals turn rate start time dot delta time. I'm just going to say I can make this general because I'm going to have to do this again for pitch. So instead of that, I'm just going to say this is current Euler angle. Okay, and I'm going to call this current Euler, and it should be angles because it's actually 3 angles in the x, y, and z components. Right, and then I'm going to say, and it should be current, right? So I'm going to say current angles dot y. Okay, the problem is this should be, I want to refactor this. This should be lowercase c because that is our convention. Okay, done. Everywhere it's been refactored. So I'm going to do this the variance. So this is fine. I'm going to do this a little bit later. So, okay, and that makes the code a little bit nicer because I don't need extra lines for that. So I'm going to say now Q and E, I'm going to add. Okay, now I can say this, right? Oops. Then for the pitch, I have something like this. What are the pitch keyboard strokes? I think we said Z and X. So let's say dot Z, and in this case it's going to be rotation around X, and we'll say minus, and this will be rotation around X, and this is CX. It's actually X. Okay, are we good? And then so this has both rotation around X and rotation around Y, but this should be happening to the pitch node because we agreed that all this will only happen to the pitch node. So let's look at this again. Current Euler angles. So it's going to pitch the node both by yaw and by pitch. So we don't want to do that. So we're going to have to do current Euler angles. Let's call it current yaw. Right, and the next one will be current pitch. Okay, so what I'm going to do is I'm going to call this and rename it. And I'm going to rename it with yaw here. So, no problems, all right. So current yaw, and then before I do this, I'm going to say current pitch Euler angles equals yaw node dot transform dot local Euler angles. Okay. And then I'm going to say, no, that's not right. There we go. Say YANO dot transform dot local angles equals current Euler angles. Separate ones. This should be current pitch Euler angles. As should these. So we have two different Euler angle temporary variables to hold the current value of these transforms. If you want to add, we're going to add some more. I should just have tested yaw first and then added the stuff for pitch. But I've done both because in a bout of overconfidence, I did this. Let's see how we do. Compile, compile. All right, finished compiling. Okay, I'm going to move a little bit over here. And if I do this, oh, I'm turning. Okay. I'm moving the direction that I turned. All right, so. I don't know if this is exactly the right thing I want because it's moving as well. How about pitch? Ooh. Oh, that is weird. It's moving a lot. So let's go back here. And look into this. Well, I'm looking at this, and if you look carefully, oh, it's at 0, 0, 0. There's some translation going on that is not clear. Oh, wow. Oh, this is not at 0, 0, 0. We want it to be 0, 0, 0. Everything, right? And this is the thing that should be at the location of the RTS camera. There we go. We want to start out over here. We'll start out at 50, minus 50, okay, maybe minus 100. I can see that. I'm going to start with a rotation of 20. Okay, so everything else is at 0, 0, 0. So now when I do stuff, things should be much better. Let's see. All right, I go here and then I yaw. Oh yeah, I'm turning. And then I go this way. And I'm turning. Ah, yeah, that's the problem. I can't deal with the pitching. So I'm going to make this 0. There's no pitch when we start. We want pitch when we start. We have to play with the pitch node. So I can say your starting pitch is 20. Okay, and everything's okay. I can't save it. But if I do this, then I'm back to where I was. I can go here, here, and I can go here. Okay, this is much better. This is what I want. It's kind of slow. So I think you should current pitch. Okay, let's camera turn right. Let's make it 50. All right, so then if I turn it, okay, that's better, faster. Okay, it's not, it's turning nicely. If I do the pitch up and down, it's fine. So if I do this, right, I can go up and down. Right, and I can go way up here like this. Nice. right? And I can look to the horizon, look straight down, get close, and go look up, and over. Okay. This looks good. Okay. Now the last thing I want to do is to say one of the things I would like with the DDG, apart from the mesh and stuff, is to add a camera rig node, which is where the camera rig, right? So each entity will have one of these, and that's where the camera will attach itself. Okay. So now, where should this be? Okay, where are we? Okay. 0, 0, 0. So where do you want to be when you see stuff from here? I think I want to be like a little bit up. If it's a third-person view, probably all the way back here. I may not want to see. Is that a good spot for it? Say maybe over here, up like that. And because I like nice multiples of 5 and 10, I'll say 45 and minus 35. All right? And I don't want to give it a starting picture. It should be all 0, 0, 0 except this particular. The only thing that should change is the location. All right. Then what I like to do is take this and attach it here so that then I get that particular point of view. Right? Okay. If I do 0, 0, 0, there's the point of view I would have. And that would be my third person point of view. Maybe I actually want it, where do I want it? Maybe a little lower, and maybe a little ahead for 0. Or maybe even ahead of that. Okay, maybe this is the point of view I want. Okay, I'm like I'm in front of the ship. I can also do this, right? No, that's too much. If I do there, I have to go higher. Oh, geez. Okay, there's a mast that goes high. Maybe that's the third person view for me. That's where I should be. So, minus 119, so minus 120. And we'll say 32. Not a multiple of 5, but at least it's whole number, integers. Okay, so go back here. And now what I need to do is, if I hit a C, I should detach this from here and attach it to here, to the selected entities camera rig. So finally I'm going to say if, oops, I don't know what's happening here. If input.get key, and this I want to say up because I just want to do it once. Key code dot C. What do I want? I want to say if is RTS mode. So I'm going to need a variable called that very soon. I'm going to do something, otherwise I'm going to do something else. So let's create, this is getting really long. I'll put the variable here. Public boo is RTS mode equals true. So because it starts out in RTS mode. So if it is RTS mode, we want to toggle it, right? We want to say is RTS mode equals the opposite of what it was. So not is RTS. Not. If it was true, it will become false. If it was false, it will become false. And then what we want to do is we want to take the yaw node dot transform dot parent or set parent, and we tell it the parent should be the ship. So it's selection manager dot inst dot selected entity dot camera. Oh, it doesn't have camera. Oh, where do I don't have a place to put it. So for now I'll just say it's a child of this because it will compile. What I have to go back and do is now I have to give somewhere over here, I need to tell it where the camera rig is. Okay, so I'm going to put that with entity information. All right, so let's go here. Entity 381. I'm going to say, other miscellaneous stuff, public game object camera. Oh, it has to be camera rig. This is where you put the camera. Okay, so we go here and we say yeah. So that's what we do. So let's see. Is it coming up here? Camera rig. Okay, it's got nothing. I'll get an error unless I set it. So for DDG51, everything is set up, right? Okay. Before I test it, before I go on, just let's see if this actually works. I won't be able to go back, but at least I'll be able to see if this works. So let me start by saying I'm at 50 minus 100. Reset position. Okay. I have to reset the position every time. That's what I have to do. So over here, I have to say mount. Say yaw node dot transform dot reset position. Okay. No rotations, right? Yeah, you can just say local Euler angles is vector 3.0. Okay, so there's no running is nothing weird going on. So I've set, so it reinitializes it to that position. So when you move it, it doesn't keep the position it had. It just reinitializes it, and then it reparents. Okay. This might work, but I want to make sure. So let's look at this and say search transform reparenting. Oh. Okay, let's just say does set parent really what I want? the world position there. So I could have just called it with this. No, I don't want it to do either one. I just do need to set it to 0. Okay. I need to do it after, I think. Okay. I think I may have to say false to make this work well. I'm not sure I understand what they're saying, so let's check it out. Right, everything's going fine. I'm in the world. I'm over here, and I press C. Okay, I'm here. Then I press C. I should go back, but I can't do that because it doesn't really do anything. I don't have the other parts. At least this part seems to be working. All right. Oh, wait a sec. When I'm here, can I do all the other things I could do before? Okay, C. Can I go? Oh yeah, I can do all this stuff. Right? All relative to that. And then I can rotate, I can go this way, look around this way. This, okay. Okay. This is great. Nice. So then else, well, we're going to do this anyway, so this should be outside the if and else. Nicely done. All right, so what do? I say I have to go back to that node, so I'm going to do something like this, except I'm going to transform and set parent to be camera, RTS camera rig. That's where I need to be. Dot transform. All right, and then I reset things to 0. And then, either case, next time it should go the other way. Okay. All right, it's playing. I can move. C. Okay. C. Okay, I go back. C. All right. So this time I go up here, maybe, and then I hit C, and I go up here. Suppose I make it end up over here. All right, I'll make it end up really high. And maybe it's looking down a little bit. Right. If I hit C, what happens? Oh, I end up looking down instead of looking up like I was before because I carry the pitch over. This is close to what I want, but not. I should probably store the pitch of the old location and then reset it to those values. And then when I jump to a selected entity, I need to find the values of pitch over there and then set it. But for now, I think we'll be satisfied with this. We can jump back and forth from the RTS to this. Some of the transformations carry over, but at least the movement always reinitializes itself to the same position. Cool. Okay. Still too slow. Did I not save it? Yeah, I need to make this like 30 or something like that. It's really slow. Okay, so that's saved. Okay, so I think we've done most of what we wanted to do. we've got the camera manager, and then next thing is how to deal with prefabs and to make everything with prefabs. That is a movie for another time, another tutorial.